take a look at this Chapter 9 test review. And, okay, I'm ready to start. And, radicals. Okay, so, this first problem here says simplify the radical. So we got the fifth root of 32. Well, we want to do the prime factorization of 32. So we're going to have 5 2's. Now let's say you don't see that. Well, we can do our tree breakdown. And remember, our primes are 2, 3, 5, 7, and 11. There's actually a lot more than that, but that encompasses about 95, 98% of what you see in algebra. Okay, I start with my first prime, the 2, and ask myself if it's divisible by 2, and it is. 2 times 16. Now 2's primes, we circle it. And then we look at 16. We're still on our first prime. We ask ourselves if it's divisible by 2, and it is. 2 times 8. 2's primes, we circle it. Then we work on the 8, and we're still on the first prime, which is 2, and 2 times 4. 2's primes, we circle it. And then 4 is 2 times 2, and both of those are primes, we circle them. So that's how we get 5 2's. Okay, now our index is 5, which means we're going to look for a set of 5 of something. Here's 5 2's. So this 5 2's is going to come out in front as a single 2. There's nothing left inside the radical, so it disappears. So our answer is just 2. Okay, 9 to the 3/2 power. Whenever you have a number to a fractional power, rational exponent, and number up on top is greater than 1. Then we'll go through our steps. Now our first step is to take the number that's in the numerator, number up on top, put it on the outside of the set of parentheses. So this becomes 9 to the 1/2, all raised to the 3rd power. We got a property that allows us to split them apart like that. Step 2. Rewrite what's inside the parentheses in radical form. So this is going to become the square root of 9. Now how we do that is whatever number's on the bottom here, that's your index. That number goes in this slot right here. Whatever number's up on top, that's your power. That's what goes right here. Well, we know if we have a 2 as the index, we don't need to put it. That's just square root. And 9 to the first is just 9. So then we work with a square root inside, a radical that's inside. And if I did prime factorization of that, 9 is 3 times 3. Now our index is 2. Again, square root, your index is always 2, so we're looking for a pair of somethings. Here's a pair of 3's. So a pair of 3's is going to come out in front as a single 3. Then that 3rd power just carries down. And then our last step is to simplify what's left. Well, 3 to the 3rd is just 27. And that's our answer. Okay, let's take a look at this one. We've got x to the 10/9 over x to the 7/6. The instructions are to simplify it, use positive exponents only, use integers or fractions for any numbers in the expression. Well, whenever you have a fractional power like this, and I'll bring up my calculator. And since I'm bringing up my calculator, let me briefly touch upon the second one. And the first one, actually, you could even plug in your calculator, but it's good to understand the concept of what the index means. Because it may not come out perfect like that. And the second one may not come out perfect. But if I wanted to check 9 to the 3/2 in my calculator, the trick is whenever you have more than a single number or single variable in your exponent, put parentheses around it. So I do 9 caret, beginning parentheses, 3 divided by 2, closing parentheses, enter. And it gives me our 27 I found. Okay. Well, if I was doing this by hand, let me do that first. We know we got x to a power over x to a power. We subtract a smaller exponent from a larger one. So the question is, which one's a larger one? That's not so easy to see, but we know that when we're subtracting fractions, it's beneficial if they have the same denominator. So what I'm going to do is I'm going to rewrite each of these with the same denominator. So I look at 9 and 6, and I'm looking at the LCM of 9 and 6, which would be 18. So I'm going to rewrite each one of these with that new denominator. Now looking at the 10 ninths, I look at my old denominator, the 9. I ask myself, what did I multiply it by to get to 18? And I multiply by 2, so I have to multiply the top part by 2. So 10 times 2 is 20. Now this fraction down here, I look at the 6 and I ask myself, what did I multiply by to get to 18? I multiplied by 3, so we have to multiply the 7 by 3, which gives us 21. Now obviously, the larger one is down here. So again, if you have x to a power over x to a power, you subtract the smaller exponent from the larger one. Let's try to write a little bit better. There we go. So 21 eighteenths minus 20 eighteenths gives us 1 18th, and we have x to this power where our larger exponent was, which was on the bottom. So I got x to the 1 18th, and then placeholder of 1 up here. When everything disappears, you're always left with a 1. Now, right up here, 10 ninths and 7 6. Well, if I were to subtract them, and again, the question is, which one's a larger one? Well, if I do 10 ninths, so 10 divided by 9, minus 7 divided by 6, and press enter, you get a negative. That means you have it flipped around. The larger one is a 7 6. So I do 7 divided by 6 minus 10 divided by 9, and press enter, and I don't get a negative, which means that my larger one is a 7 6 and the smaller one was 10 ninths. Now I got a decimal here. If I do math, enter, that'll give me my 1 18th. So you could have just immediately went from here to this step right here, if you wanted to use your calculator to do the fraction part. Well, let's enter this in. Which is probably not trivial by itself. Okay, I got a fraction. I put 1 there, x to some kind of power, 1 18th. And I'll do 1 slash and then 1 18th. It automatically puts it in fraction form for me. And next question. Simplify, and we got this. Okay. As much as possible, I'll try to do these using the order of operations. Sometimes it's tempting to ignore those. So I got a to the 7 6, b to the 4/5, raised to the 5/7 power. Well, order of operations says do what's inside the parentheses first. Well, there's nothing to do inside the parentheses. We got a to a power times b to a power. We can't do anything there. There's no negative exponents. Nothing to simplify. So, if everything inside of your parentheses is either multiplication or division, and you're raising it to a power, you can take everything to that power. So I can take the a to the 7 6 to the 5/7 power, and the b to the 4/5 to the 5/7 power. Okay, so we got a to the 7 6 raised to the 5/7 power, and we got b to the 4/5 raised to the 5/7 power. Well, these 7's going to cancel here, and these 5's will cancel here. Rule is when you're multiplying fractions, which would be your next step, you simplify first. And if you got a number up on top and a number on the bottom, both divisible by the same number, then you divide them. 5 and 5 both divisible by 5, so that's why we cancel those. Which gives us a to the 5/6, b to the 4/7. Let's say you stink at fractions. And at 7 6 times 5/7, you want to do it on your calculator. Well, 7 6, so 7 divided by 6 times 5 divided by 7. Enter, and then you get a decimal, you do math, enter. And that gives us our 5/6 right here. Okay, so a to the 5/6. B to the 4/7. And next question. Okay, square root of 24. This is why earlier I mentioned it's good to know the concept, because this does not come out perfect. Problem is this, 5 square root of 24. Well, if I did prime factorization of that, I start with my first prime, which is 2. It is divisible by 2. 2 times 12. 2's prime, so I circle it. I'm still on my first prime. 12 is divisible by 2. 2 times 6. 2's prime, so I circle it. 6 is divisible by 2. 2 times 3. 2's prime, so I circle it, but also 3's prime, so I circle it. So we're going to have the square root. We got 3 2's and 1 3. Now remember, with square roots, we're looking for pairs or something. Here's a pair of 2's, so a pair of 2's is going to come out in front as a single 2. And we're left with 2 times 3 inside. Can't bring anything else out because there's no pairs of anything. No pairs of 2, no pairs of 3's. So 2 times 3 just gives us 6. So our answer is 2 square root of 6. So 2 square root of 6. Cube root of 54. Well, if I did prime factorization, 54, start with my first prime 2. It is divisible by 2. 2 times 27. I'm still on my first prime, which is 2, and 27 is not divisible by 2. It'd have to end with 0, 2, 4, 6, or 8. So I'll go to my next prime, which is 3, and it is divisible by 3. 3 times 9. 3's prime, so I circle it. I'm still on 3, so and this is divisible by 3, so 3 times 3. So our prime factorization, we're going to have 2 times and then 3 3's. Now our index in this problem is the cube root. The index is a number in a slot is a 3. Means we're looking for a set of 3 of something. Well, here's 3 3's. So those 3 3's are going to come out in front as a single 3. And that would be our answer. 3 cube root of 2. So 3 cube root of 2. Check that. 3 cube root of 2. Okay. Next question. X to the 7th. It says simplify by factoring. Assume that all expressions on the radicals represent non-negative numbers. When they say represent non-negative numbers, they're telling you they're positive, which means you don't have to worry about putting absolute value bars at all. That's the only thing they're telling you there. So we got square root of x to the 7th. Well, if we were to look at our index, square root, your index is 2. It's by default there. You don't actually see it. To figure out how many x's is going to come out, we'll use the shortcut. Though this one's probably small enough you could actually just do it. With our shortcut, remember, we take our power, divide by our index, and this is old style division. So we got 3 with a remainder of 1. Don't want any decimals. Again, this is our power, and this is our index. Now this is how many come out, and this is how many stay in. So that means I'm going to have 3 x's come out. So I got x to the 3rd, square root, and we got 1 x left inside. So we got x to the 1st inside there, which is x to the 3rd power square root of x. And that's our answer. So x to the 3rd square root of x. Next question. Let me grab a drink here. I think I got room here. Let me start a new page. Okay, we got square root of 28 plus 2 square root of 7. No matter where you are in math, if you can simplify your radicals, you should before you go on. Now 7's prime, so I can't do anything with it, but 28 I can do something with. If I did a prime factorization, start with my first prime 2. It is divisible by 2. 2 times 14. 2's prime, so I circle it. Now I go to 14. 14 is divisible by 2. 2 times 7. 2's prime, so I circle it, and 7's actually prime, so I circle it. So this becomes square root of 2 times 7 plus 2 square root of 7. And remember, with square roots, we're looking for a pair of somethings. Here's a pair of 2's. Pair of 2 is going to come out in front as a single 2. Now when you're adding or subtracting radicals, if the radicals are the same like this, then you add or subtract the numbers that are out in front. 2 plus 2 is 4, square root of 7. And that's your answer. Okay, let's take a look at this one. Number 9. We've got square root of 2 and square root of 7 plus square root of 14. Well, always simplify a radical before you go on. So let's look at that first. 2 I can't do anything with. 7 I can't do anything with. But 14, that's 2 times 7. Well, it doesn't help us any. I can't bring anything out. So let's go ahead and perform the operation then. Something in front of parentheses like this, where you have like a single radical, single number, single variable, that's the distributive property. So we're going to take this square root of 2 and we'll multiply it times the square root of 7 and times the square root of 2 times 7. So square root of 2 times square root of 7 and square root of 2 times square root of 2 times 7. Now when you're multiplying radicals together, what you do is you multiply what's underneath radicals, put them underneath a single radical. So we're going to have square root 2 times 7, and over here square root of 2 times 7. So just put them underneath one radical. Now we don't actually multiply them together to begin with, because we're hoping to see if something will simplify. Remember, we're looking for a pair of somethings, and right here we see a pair of 2's. So a pair of 2's is going to come out in front as a single 2. Now here we don't got a pair of anything, so I'll go ahead and multiply them together. 2 times 7 is 14. Plus, a pair of 2's came out as a single 2, and we're left with a 7 inside. So that'd be your answer. Square root of 14 plus 2 square root of 7. Let's take a look at this one. 1 over square root of 14. This is number 10, I guess. Well, to begin with, we try to simplify our radicals, but this, again, 14 is 2 times 7. I can't do anything with it. Now, our problem here is we got two conditions when we're talking about fractions and radicals. One of them is no fractions inside of a radical, and the other one is no radicals in denominator, which is what we have here. If you have a single item down here, single radical in this case, then what you're going to do is you're going to multiply top and bottom by the square root of 14. And that'll always happen when you're talking about square roots. Now, you should always simplify this first, though, because otherwise you might get some huge numbers and have to do more simplifying at the end. 1 times square root of 14 is square root of 14, and square root of 14 times square root of 14 is 14. So that's our answer. Square root of 14 over 14. Okay, now this one's a little bit different because it's not a square root, so let's see how this one works. We've got negative 3 over the fourth root of 2c to the third. The reason why the radical disappeared over here is because we're dealing with square roots, means our index is 2, which means we need 2 of something. We had 2 14s. That's why it came out as a single 14. On this one, we need, our index is 4, means we need sets of 4 of something. Now I have 1, 2 here, so I'm going to put in 3 more 2's because I need 4 total. Now I had 3 C's, so I'll put in 1 more C, and that'll give me 4 C's. And whatever you multiply by the bottom, you have to multiply by the top. Okay, up on top we got negative 3, 4th root, 248C over. We have 4 2's, so those 4 2's comes out as a single 2. We have 4 C's, so those 4 C's comes out as a single C. Now the question becomes, do we need the absolute value bars or not? So let's go back and read the instructions. Assume that the variable is positive. That says we don't need to put absolute value bars on the C. So that's our answer. Let's see, negative 3, 4th root of something, 8C, over, was it 2C? Yeah. Okay, find the domain of f. So number 11, or 12. Got f of x is equal to the square root of 7 minus 5x. Now to find the domain, we can't have negative numbers in here. So we're going to take what's underneath the radical and set it greater than or equal to 0 and solve. This applies whenever you have an even index. If this was an odd index, our domain would be all real numbers, negative infinity, positive infinity. Okay, so I'm going to take the 7 over, it becomes a negative 7. And then I'm going to divide both sides by negative 5. And remember, if you divide by a negative number, you flip your inequality symbol. So we got x is less than or equal to negative 7/5. Question is what form it's wanting it in. Just type your answer in interval notation. It's a less than, so it's going to negative infinity. Specifically, it's got the line underneath. Remember, the line underneath means you put a bracket. So that'd be your answer. And how do I put that? Look at that. Negative infinity, comma, negative 7/5. And bracket. Kind of looks weird. I guess that'll give me an error if I put it in wrong. I might have had to choose more for bracket here or something. Yeah. We'll see if it counts it wrong. I'm just curious at this point. Okay, solve the following equation. So we got square root of 2t plus 49 equals 9. Okay. Radical equations. First step, get a radical by itself. No numbers in front of it, no numbers after it. Well, that's what we have here. So our second step, raise both sides to a power equal to the index. When you got a square root, then your index is automatically 2. So we're going to square both sides. When your index matches the power you're raising it to, they're going to cancel each other away and leave you what's underneath the radical. So you got 2t plus 49 equals 9 squared is 81. I'm going to take the 49 over to the right side. It becomes a negative 49. Which gives us some 32, I think. Yeah, 32. Then divide both sides by 2. And we get t is equal to 16. And I guess they're just wanting us to put 16. Okay, let's take a look at this one. Better start a new page. This looks like a harder one. So got square root of 3x plus 25 equals 5 plus square root of x. Now our steps for solving a radical equation says first get a radical by itself. Well, this radical is by itself. Nothing in front of it, nothing after it. So it's by itself. It doesn't say which one, so this one's fine. So then our next step, step 2, is to square both sides. Raise both sides to a power equal to your index. And again, when your index matches the power, they're going to cancel each other away. So you got 3x plus 25. And over here, we're going to rewrite this as 5 plus square root of x times 5 plus square root of x. I can't just square the 5 and square the square root of x because of the plus here. If everything inside your parentheses is multiplication or division and you're raising it to power, that's when you can do that. Now we're going to multiply those together. 5 times 5 is 25. 5 times square root of x is 5 square root of x. Square root of x times 5. And square root of x times square root of x. FOIL if you learned that technique. So first, outer, inner, last. So we got 25 plus 5 square root of x plus 5 square root of x. And square root of x times square root of x just gives us x. When you're dealing with square roots and they're exactly the same like this, then they just cancel each other away and leave you the x. Okay, so we've got 3x plus 25 equals 25 plus 5 square root of x plus 5 square root of x is 10 square root of x. Remember, whenever the radicals are the same, you add or subtract the numbers that are out in front. Now we're down to step 3. Step 3 said that if you have more radicals, go back to step number 1. Start over. Well, we have more radicals, so we're going to start over. Step 1 says get a radical by itself. So I'm going to take this 25 and move it over, and I'll take this 10, or this x, and move it over. So we got 3x minus x plus 25 minus 25 is equal to 10 square root of x. 3x minus x is 2x. 25 minus 25 cancels, and you got 10 square root of x. Now I had one condition in the notes I gave. I said get a radical by itself, but do not create a fraction. I could divide both sides by 10, but I'd create a fraction, so I'm not going to do that. But I can divide both sides by 2, looks like. Make it a little bit easier. So that gives us x is equal to 5 square root of x. Okay, step 2. Raise both sides to a power equal to your index. This is a square root, so we're going to square both sides. So I got x to the second power, and I got 5 square root of x to the second power. Well, x to the second power is x squared. Now, if everything inside your parentheses is either multiplication or division, you raise it to a power, then you take everything to that power. So we're going to take the 5 to the second power and the square root of x to the second power. So we're going to have 5 squared and square root of x squared, which gives us x squared equals 5 squared is 25, and when your index matches the power, they cancel each other away, so that gives us x. And now we're down to our quadratic. So we want to take 25x over, because where we're headed with this is we want to use the zero factor property. Zero factor property says get 0 on one side, factor the other side. Well, this factoring technique is GCF. They both have an x in common. So factor that out. Now, zero factor property says you get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set x equal to 0, I'll set x minus 25 equal to 0, which gives us 0 and 25, maybe. Remember, you have to check your answers. So this process will give you the correct answers, but sometimes give you false ones. So let's put 0 up here. 3 times 0 is 0, plus 25 is 25. Square root of 25 is 5, so this side would be 5. If I put 0 here, square root of 0 is 0. 5 plus 0 is 5, so 5 equals 5. This one checks. 25. 3 times 25 is 75, plus 25 is 100. Square root of 100 is 10, so this side would be 10. If I put 25 in over here, square root of 25 is 5, plus 5 plus 5 is 10. So that one checks. So 0 and 25 are our answers. Simplify your answer, use a comma to separate the answers as needed. So do 0, comma 25. And the next question. We've got square root of negative 49. Well, that's negative 1 times prime factorization of 49 is 7 times 7. Now remember, we're looking for a pair of somethings. Here's a pair of 7s. They're going to come out of the radical as a single 7 because we're dealing with the square root. And remember, a negative 1 comes out as an I. So our answer will be 7i. Negative 1 inside of square root always comes out as an I. Moment of truth. Let's see if I made any mistakes. Didn't like 12. Let's take a look at number 12. Sunrise my eyes. I did not like my bracket. So be sure when you do that, you choose the more, and you choose the big bracket, not the little bracket. Boy, that's big. Oh, wait a minute. My sign's wrong. Did I actually screw up the sign? I've erased it. I was so focused on how to enter it that... Okay, 7 minus 5x. Find domain. So you set it greater than or equal to 0. Okay, take the 7 over. Becomes a negative 7. Divide both sides by the number in front of your x, negative 5. It becomes less than or equal to, so you got x is less than or equal to 7/5. And I put a negative. I'm pretty sure I had a negative on there too. That was just a mistake on my part. So anyway, been nice if I'd finished with 100%, but oh well.